So in this video, we are going to construct a fully parametric detailed duct support family. So for this one, I'll just select this template. So click on this new, and I'll select metric generic model. Okay, and click open. So this is your metric generic model template we have opened in the family, and this is your reference plane, means you are viewing from the top. Okay, so I'll just go to the front view, and in this front view I'll draw the reference plane, because here I'll draw the cross section of the duct. Okay, so I'll select this reference plane, or you can use the short key RP. Okay, select this one, and I'll give an offset of say 350, and select this pick line, and one I'll offset give here and one here. For the height, I'll give an offset of 200 bottom, 200 the top. Okay, now I'll create the parameters, duct height and duct width. Okay, so first, for creating the parameter, I'll just measure them and make the equal dimensions, make it equal. Again, I'll select from here to here. Similarly, I'll draw for height also and make it equal. Then for the overall, okay, so this is your width 700 and 400 is your height. Just for example, I'm taking. So I have to create the parameter. So select this one. So in two ways you can create the parameter. Either you can go to this family type and create the parameter from here. Okay, this is one, and you can directly select this dimension, and here is an option for to create the parameter. So I find this more useful. Okay, so I'll use this this second option. Okay, or you can, as per the requirement, you can use whatever you the most suitable for you. Okay, so I'll select this one and select this create parameter, and this is your what, duct height, duct width, duct width, and this will be your instance parameter. What is the difference between type and instance? Type will be visible in your properties browser, and if it is instance will be visible in this properties browser, and type will be in the edit type. Okay, so because the instance you can have means you can individually change for a particular duct support. Okay, so that is why we are choosing this for instance. Mostly all the parameters what we'll creating in this duct support will be instance type, not the type. Okay, so this instance and click OK. Duct width, select this one, go to this create parameter, duct height, and instance, click OK. Okay, now so this is what we have done, what we have created, the references and the parameters. Next, I'll draw the extrusion of this particular duct. Okay, so to create the extrusion, I'll go to this create tab. Here you will find this extrusion. Select this extrusion, and I'll select rectangle from here, and I'll directly draw a rectangle. Make sure to lock these lines, otherwise it will not move according to the parameters. That is why we are locking here. Okay, this is very important, don't forget this. And I'll give a depth of say 20 mm. Okay, and finish. Just have a look in the 3D view also, and here we have, make it realistic. Okay, that's good. Now coming to the reference plane, means viewing from the top. Okay, so from the top also what I'll do, I'll create the reference plane. Okay, giving an offset of 10, select this pick line, and one offset I'll give to here, and one offset I'll give here. Okay, and Then I'll create the parameter. Okay, so select this one. From here to here it is 20, means it is the depth. Okay, depth of the duct piece that I have created, and this parameter is your depth. You can say depth, instance, and 20. And what I'll do, I'll link this one. Okay, because I have to align this particular duct piece with these, in between these two reference planes. So I'll use this align tool. Select this align tool, select this one, and then this line again, and lock, and select this one, select this line, and lock is very important because you are constraining it. Okay, that is why we call it as parametric, because it will move according to the parameters that you can edit in the project. Okay. Now, okay, and now I'll come to the 3D view, and the next step is to apply the connectors, duct connectors. Okay, I'll come to this create tab, and where you will find in this create tab, here the connectors, duct connector. Okay, so I'll select this duct connector and hover the mouse on this face when it becomes red and click. Okay, then what, select this connector, and you have to align with the dimensions of the duct. Okay, so I'll select this one. Here is an option for height and width. Okay, so I'll select this width and link with duct width. I'll select this height and select link with the duct height and click OK. So it will take the dimensions according to the duct. Okay, next what we have to do in this one, we have to set the system classification to global. Okay, this is very important because support will be used for all the ducts, either it is an exhaust, supply, return, whatever is there. Okay, so I'll set it the system classification to global. Okay, similarly I'll do for the back face also. For this face I'll create, go to the create, select the duct connector and select this face. Okay, then select this duct connector, go to this height, link the duct height, click OK. Again the width, duct width, click OK, and the system classification set to global. Okay, next what we have to do, see these are the two different connectors, they don't have any link in between. Okay, so what I'll do, I'll create one link between these two connectors. Okay, so firstly I'll make it wireframe. Okay, then I'll select this connector, and here is an option for link connector. Click on this link connector and link with this one. Okay, now when you select this one, you see there's a symbol for the linkage. Okay, you might be thinking why we are linking them. Okay, so we are linking these two connectors to designate the flow. If you do not link that, then the flow will not be transferred to the other side. That is why we are linking them, to designate the flow. Okay, because in all the fittings, either it is a damper or any kind of duct accessory and duct fittings, the connector should be linked, okay, to designate the flow. Okay, so next, after linking them, and what we'll do, coming to the front view. Okay, and in this front view, next step, we have to create a support. Okay, so next we are going to create the support. Okay, so for this one I'll open one detail. Based on that we'll model that particular support. Okay, so I'll open this Just 1 minute. I'll open that particular page. I think 63. That you will find. Okay, this one. And in this one, you see we have a support detail. So this is your duct that we have created, and from this duct there is a 50 mm gap from the rod to the duct and 25 mm overhang. Okay, so total length how much? This is your duct plus 50 plus 25. It is how much? 75. Okay, 75 plus 8 mm rod, which is equal to 83. So 83 offset from this side and 83 offset from this side. That will be your total support length. Okay, so I'll create that one. For that one, same procedure. Go to this create, select this reference plane, and select this pick line, and I'll give an offset of 83. Okay, from the duct. So I'll give one here and one here. Okay, and next what we'll do? Okay, we are on the front. Select this dimension, make this equal. Okay, and again select from here to here. I'll give it in the bottom, and this will be your support length. And make it instance and click OK. So this will be your support length. Okay, also you can create a form like this one. Okay, so it will be automatic. How you will create? Go to this parameter type. Okay, parameter type, and here is the support length. No? So support length will be how much? We have created 83. So 83 plus 83 how much? 83 plus 83, 166. Okay, so select this duct width, Control C, Control V, plus how much? 83 plus 83, 166. So you can specify here 166. Okay, and click apply and click OK. So it will automatically take. You don't have to input again and again. Okay. Next, now we have to create the angle. You have seen in this detail. This is your angle. 40 by 40 by 5 mm. 5 mm is the thickness. This one. So just let me move this one. So 5 mm is the thickness of this angle, and 40 is this length and 40 is this length. So 40, 40 and 5 mm thickness. So this profile you have to draw in this Revit to create the family. So for that one, I'll come to this new, and I'll select what? Metric profile. Okay, select this open. And in this one, I'll create a particular profile. How? Select this line and 40. Okay, again down 40, and here how much? 5. Okay, then again I'll move this one 5, and then trim this one. Okay, so this is your profile. You can check 40, 40, and this is your how much? 5. Okay, so I'll delete this one, and I'll select this profile and move it to the middle point. Okay, then you can zoom it. I'll come to the visibility graphics, and you can hide this annotations and all. Okay, and here is the section type. Okay, you can specify the section type, which is L angle. Click OK, just for the detail purpose. Okay, and then you can directly load into the project, load into the family. Okay, that we have previously created. But before that, I'll save this one, family. Okay, on desktop, I'll create one parameter, duct support, and this is L profile. Okay, and save. Okay, then you can load into the project. Okay, now it's being loaded. What we use now, we use sweep command, because that same profile we have to sweep now in the total support length. So I'll click this sweep tool, then I'll select this sketch path, then I'll select this middle line and lock this, make sure to lock. Then you have to trim this one according to the support length. Support length is how much? From this point to this point. Okay, so I'll use align tool for this one. Select this align tool, select this line, select this point, select this line, and select this point. Okay, just 1 minute. I forgot to lock this. Select this line and select this one and lock. Select this line and select this point and lock. Now we have specified the length of that particular profile and click finish. Okay, then you have to select the profile, which is L profile. We have already saved it because loaded in this one now. L profile and finish. And if you see in the 3D view, you see we have profile, but this profile should be in the bottom. Okay, realistic. So I'll come onto the front view, okay, and select this profile, okay, and add it work plane. Pick a plane. Which plane? This one. Work plane has been changed. Okay, now you can see in this view we have this L angle. Okay, now it's perfect. Next, what we have to do, the second, this one, we have created this angle. Now we have to make this rod. Okay, so this is how much? 25 mm plus this is 8 mm rod. So I'll take 4 mm. So 25 plus 4. You can take 30 mm. 30 mm. This overhang. So you have to give a reference plane for this one also. How? Coming to the reference level. Okay, and I'll give one reference. Go to this create reference plane, pick line, and I'll give an offset of say 30 mm. Okay, and I'll give an offset here. Okay, same from here to here. So you can see here, I'll give the dimension for this one also. Here to it is 30, and from here to here it is 30. And these two are the parameters which I'll create with the name rod insert. Okay, rod insert, or you can name it up as per the term, overhang or whatever you want. Rod insert 30 mm. Click instance and click OK. Okay. Next, so this is the rod insert. Now we have to model the rod. So I will not use this same family to create the rod. I'll use another metric generic model template, and then I'll create that rod, nuts and washer, and then we'll load in this project. So that will be very clear, because if you create in this one, it will become very, it will become. So I'll go to this application menu, go to this new, and again I'll select metric generic model. Click open. Okay, so this is metal churning bottle for your rod. Okay, so in this one, what I'll do first, I'll create a reference plane and like this pick line. So washer thickness I'm giving say 2 mm. Okay, and origin 5 mm. And here will be your angle. So angle thickness is how much? 5 mm. So I'll again give a reference plane of 5 mm, pick line, and I'll draw one here. Okay, and this I'll make uh, 5, and I'll change it to 2 mm. Okay. Same. Now you can delete this. Same. I'll give a 2 mm on the bottom side. A reference plane, pick line, and give it 2 mm. Okay. So this is the thickness for your washer. Okay. So I'll come on the front view. Okay. Okay. I think we have to do in this reference plane. So I have to delete just 1 minute. Delete this one. Delete this one. This is coming to the front view, and I'll give an offset decline 5 mm below, then 2 mm for washer. Okay, and from the top, means from the reference plane, I'll create the washer. Okay, and washer die I'll take say 18 mm. Okay, so I'll select this extrusion and select this circle, and dia is 18 mm for washer. Okay, and finish. Coming to the front view, and you see this is up to the top, but I have to align this up to this length 2 mm. So what I'll do, I'll select this align tool, select this reference plane, and select this one. Okay, and lock. Same you can copy for bottom also. Select this one. Firstly now we are modeling this washer. Okay, same you can select this one, copy, and edit work plane, pick up plane. Okay, this one, and you can give a minus offset of 2. Okay, so this is your washer. Now after washer, we'll draw the nut. Okay, nut and bolt. So I'll come on the reference plane, and here I'll go to create, select this extrusion, and select this circumscribe polygon having 6 number of side, and depth say for example now I'm taking 25 for example, and I'll draw from here. Okay, die I'm taking 15. This one, circumscribe, and 15. Okay, and you can finish. Make this one coming to the front view. Okay, so this one just I'm taking the extrusion start 2 because this is 2 mm thickness, and the height I'll take 6 mm. Okay, or I'll increase the height say 10. Okay, similarly I'll for the bottom also I'll create one like this one. Copy, pick this point and this point, then edit the work plane, pick a plane, reference level, and I'll select this reference plane. I'll give an extrusion start -2, okay, and extrusion end -10. Now it's perfect. Okay, I'll check the 3D view. And make it realistic. Okay. Okay. So next, coming to the front view, what we have to do, we have to create the rod. Okay, this is a rod now. Rod we have to create of 8 mm dia. Okay, so for that, coming to the reference plane, go to this create extrusion. Then I'll select the circular and I'll draw a dia of 8 mm. Okay, 8 mm dia, and finish. Coming to the front view, and this I have to take it onto the top now. So for this one, I'm creating one reference plane here, and I'll give the dimension support height. Okay, support height. Or you can say rod length. Rod length, and click OK. And I'll this one is to 2. Okay, 1:2, 1:5. So this I have to lock up to this reference plane. Okay, so I'll select this align tool, select this reference plane, and select this extrusion and lock. Okay, and the bottom, you can select this one and go to this create, go to this model extrusion, align, select this one and select this. Okay, now you see extrusion start is -7, but at the bottom also we have taken, because you see in this one now it is somewhat bottom at this some particular length, you can say 10 mm or 15 mm. So one reference plane I am creating in the bottom also. Okay, and I'll measure this one, how much it is 80, so I'll take 50, and you can link this one. Go to this align tool and tab, press and lock. Okay, so same one I have to create at the top also, and it is fixed with the ceiling, okay, or the structure. So I'll select these two, washer and nut. Okay. And copy this point to this point and edit work plane, pick a plane, okay, and pick this plane. Now come to the view. Now it's fine. Okay, now it's fine. Now you can save this one. Rod with nut and bolt. And I'll save this work plane based, okay, because I'll use as a work plane. With the help of work plane, I'll attach in the family. Okay. So load into the project in family 3. Also okay, and place on work plane, and I'll select here. Okay, so where I have to place this one at this particular point now. Okay, one copy I'll make here also, and I'll select this one, align like this, and select this, and lock. Select this, and select this, and lock. Again, I'll select this one, and lock. Select this one, and select this one, and lock. Okay, now coming to the 3D view, so you can see these are placed on this top work plane. So we have to change the work plane also. So coming to the front view, and I'll select these two rods. Okay, and edit work plane. Then I'll pick the plane, click OK, and select this work plane. Okay, and also in this you can change the height. So that is why it is parametric. Okay, so if you change the height of this rod length, go to I'll go to the 3D view. Okay, and you can select these rods. Okay, and suppose for example I have to make it say 500 rod length, so it will be changed. Okay, or you can say 700. Okay, so as per the height according to the project, it can change. Okay, so this is how you'll draw a parametric family. And one thing at last you have to do, you have to specify the family category. Okay, so coming to this family category, and I'll select the duct accessories and the part type to be a damper type. Okay, you can select this one, and because it comes under the duct accessories, okay, that is what I'm selecting, and click OK. And one last parameter that you have to create for this one, because the rod length is the parameter of this particular family. Okay, this rod length, but for this whole duct family, you will not find the rod length, so you cannot change the rod length from the project. So for that, what we'll do, we'll create one family name as rod length, make it instance type. Okay, and click OK, and say for example I given of 500. Okay, and click apply, click OK, and when you select this one, these two rods, there is an option for rod length. Okay, so you can link this rod length parameter with the rod length of the family parameter. Okay, this is from the rod length which you created for the rod family. Okay, this is your support family rod length, and click OK. Okay, now you can directly load this into the project. Okay, so after completing this family, we'll set the visibility of this particular family, that at fine, medium, coarse, what are the elements should be visible. Okay, so these two rods are too detailed, so that's why I want that these two rods should be visible when the detail level is fine. Okay, so I'll select these two rods, and here is the visibility graphics, or you can type VG, and you can directly click from here also, visibility settings, directly from here, and here is an option detail levels. So I'll uncheck this coarse and medium, and this rods should be visible in the fine detail level only. So I'll click this one. Okay, and these this angle should be visible, not in should be visible only in the medium and fine, not in the coarse. Okay, so I'll click OK. So codes, this will not be visible. What should be visible? Okay, I want to draw another family for this one. So I'll go to this reference level, and what I use, I use one extrusion tool and select this pick line and select here, lock, select here and lock, and one I'll draw here, unlock, and one I'll draw here, unlock, and then you can trim this one. Okay. This, and this. And depth, how much? I'll give a depth of 40 because angle size is 40. That is, I'll give it a 40, and I'll go to the 3D view, and you can change the work plane from the front view, like this one, and edit work plane, pick up plane, okay, and select this one. Okay, and the extrusion should be in the negative side, means 40, minus 40. Okay, now have a look on the 3D view. So this solid rectangle should be visible only when the detail level is coarse. Okay, otherwise for fine and medium, this angle will be visible. So one tool we have to check this visibility setting is this preview visibility. Okay, so I'll open this on, make it on, this preview visibility, and when you make it fine, this complete detailed family will be visible. When you make it medium, only this angle will be visible. When you make it coarse, this solid rectangle will be visible. So this is how to set the visibility of a family into the project. Okay, and you can make it off, and you can make it fine. Okay, now I'll open one some project, mechanical template, click OK, and I'll go to the system tab, select the duct. Okay, and I'll give duct of 700 by 300. Okay, next I'll give 1200 by 500. Okay, or say 1800 by 600, 700, then turn, then again turn, and I'll give a reducer 1000 by 500. Okay. And coming to the 3D view, make it realistic. Okay, and make it fine. So I'm coming to the family, and I'll load this family to the project 2, and I'll attach here, one here. Okay, let's take the 3D view. Here we have. Okay, and you can adjust the rod length. See, the rod length is very much less compared to duct height, so you can adjust here. Okay, and rod length, I'll make it 1000. Okay, now it's okay. Just like this one, create similar, and one I'll draw here, and one I'll draw here. So according to the height, according to the width of the duct, size of the duct, it will automatically adjust onto the particular duct at that particular position. Okay, and rod height you can adjust as per your requirement according to the ceiling height. Okay, that is why we have a parameter. I'll make it say 700. Okay, so this is how you will draw a parametric duct support. Okay, if you have any doubt or you didn't understand anything, you can uh, write it in the comment section. Okay, oh, fine, and thanks a lot. Okay, we'll see you in the next video. Okay, soon I'll be uploading for pipe support also from family and all that I'll upload. Okay.